All right. Now, exponentials in general have an inverse function called the logarithm. Log base a of x is the inverse of a to the power x. So they undo each other. A to the power log base a of x is x, and log base a of a to the x is x. Another way to say it is a logarithm is the result of transposing an exponential. Y equals log base a of x if and only if a to the y equals x. So they invert each other. As a result, each graph is the other flip to the diagonal. If this is the graph of y equals a to the x, going through 0 by 1 because a to the 0 equals 1. You're going 1 by a because a to the 1 equals a. And you flip this graph through the diagonal, the y equals x diagonal. You get this graph here. It goes through 1 by 0 and a by 1. So log base a of 1 is 0, and log base a of a is 1. And this goes off to 0 near negative infinity. This goes off to negative infinity near 0. There's a specific logarithm, log base e of x, called ln of x, the natural logarithm. So natural log of e to the x equals e to the natural log of x equals x. It's called a natural logarithm because of this result. If you take this graph, y equals 1 over x, the hyperbolic graph, and draw a vertical line at x equals 1 and another vertical line at x equals k, this four-sided figure has 3 straight sides and 1 curved side. And the area of that figure is natural log of k. So it shows up naturally as a result of logarithms of the reciprocal function. And e to the x is one of the explosions that starts near 0, goes off to infinity. Natural log starts near negative infinity, goes to 1 by 0, and goes off to infinity very, very slowly. This goes to infinity quickly. This goes to infinity slowly. So for example, all right, so let's start doing some logarithms. Log base x of 81 equals 2, what's x? Well, you transpose a log base x on one side as an exponential base x on the other side. So 81 equals x squared, and it's easy enough. Take a square root, x is 9. Log base 9 of 81 is 2. Here, log base 5 of 125 is x. What's that? Well, the thing to do is to write 125 as a power of 5. That's 5 to the third. Log base 5 of 5 to the third. Log base 5 and exponential base 5 cancel, and you get the x equals 3. Here we have log base x of 5 to the third equals 3. What's x? We transpose the logarithm to an exponential base x. So log base x of 5 cubed equals 3 implies that 5 to the third equals x to the third. If you take cube roots, then you get that x equals 5, which you can see from here, the previous one. Log base 100 of x is 3 halves. For what x? Okay, we transpose the logarithm. It becomes an exponential on the other side, exponential base 100. So from here, x equals 100 to the 3 halves. And then, okay, 100 is 10 to the second power, 10 to the second to the 3 halves. It means you multiply the exponents. X equals 10 to the 2 times 3 halves. After a bit of cancellation, it's 10 to the third. So x equals 1,000. Log base x of root 3 over 3 to the half means what is x? You transpose as before, x, so you get root 3 over 3 equals x to the power 1/2. So square both sides, x is root 3 over 3 squared, 3/9, or x equals 1/3. You have common log of a million. By common log, that means log base 10. Your calculator will have a log base 10 button and a log base E button. You can get log base other things by a formula we'll get to later. All right, so log base, common log of a million is what? Well, it's log base 10 of a million is 10 to the 6th. Logarithm base 10 and exponential base 10 cancel out, and we are left with 6. So you have to go all the way out to a million for a logarithm or common log to get as big as 6. You have to go 10 times further out to 10 million to get to 7. Let's see, a billion gets you 9. A logarithm of a trillion is 12. It grows, as you can see, very slowly. Common log of 1/10 is what? Well, 1/10 is 10 to the negative 1. Common log is log base 10. Logarithm and exponential cancel, and you're left with negative 1. Log base a half. of 1 over 32 is what? Well, 1 over 32 is the 5th power of 1/2. So the logarithm and the exponential cancel, and we're left with 5. Log base 9 of 3 is what? Well, 3 is the square root of 9. So we're getting log base 9 of 9 to the half, logarithm and exponential cancel, and we're left with 1/2. Natural log of cube root of e squared is what? Well, cube root is a half power of a square is a 2/3 power. So this is natural log of 2/3. And natural log and exponential cancel, log base e of e to the 2/3 cancel, leaves 2/3. Here's common log of x equals 4.24, then what is x approximately? Well, you transpose a log base e to the other side, you get an exponential base e. So x equals e to the power 4.24, and a calculator will give you that it's about 69.479. Common log of x is negative 3.71. What's x? Well, transpose a log base e and get exponential base e. X is equal to e to the negative 3.71, which is about 0.0245. Okay, so that's the very, very basics to be told about logarithms. All right. Let's see what we have here.